Petroleum, or crude oil, is taken out of the ground as a mix of impurities and highly flammable compounds of hydrogen and carbon called hydrocarbons. It's processed into many products, including gasoline and diesel fuel. Gasoline is used in different forms in different engines. It's very volatile, mixing easily with air to form gas or vapour. The more effectively liquid gasoline is changed into vapour, the more efficiently it burns in the engine, so high volatility is desirable. And if liquid gasoline is heated, it is even more volatile. However, if it vaporizes in the fuel line, bubbles of vapour can block the flow of fuel and stop the engine. This is called vapour lock. There are several important characteristics of hydrocarbon-based fuels. Volatility is a measure of a fuel's propensity to vaporize. This affects the fuel's ability to mix with air and its tendency to vapor lock. The volatility of a fuel contributes to atmospheric pollution through evaporation. Gasoline, also known as petrol or petroleum spirit, is more volatile than diesel or kerosene. A fuel's octane rating is the measure of how resistant a fuel is to premature detonation or knocking when compressed prior to ignition. Higher octane fuel tends to be used in higher performance engines, not because high octane fuel provides more power, but because it burns less readily than low octane fuel, which makes it more suitable for use in high compression engines. Putting higher than recommended octane fuel into a vehicle will not improve engine performance or fuel economy. Putting in lower octane fuel than the engine requires can damage engine components. There are two ways of measuring the octane rating of a fuel. The research octane number, or RON rating, compares the knock resistance of the fuel being measured to the known knock resistance of a combination of heptane and isooctane, two reference fuels. The motor octane number, or MON rating, measures how the fuel behaves under load. In most countries, including Europe and Australia, the rating shown at the pump is the RON number. In the US, the rating shown is an average between the two measurements. Typically, the RON number is higher than the same fuel's MON number, so octane ratings in the US appear to be about 5 points lower than similar fuels elsewhere. There is also no international consistency on what the octane rating should be for premium or regular fuel. The energy content of fuels can also vary significantly, regardless of their octane rating. Gasoline has an energy content of approximately 29 megajoules per litre, compared to just over 22 megajoules per litre for LPG. The higher octane LPG therefore provides less power per litre than the lower octane gasoline. This is mainly because LPG has a much lower density than gasoline, giving less power for the same volume of fuel. When measured by mass, however, the result is different. LPG has a higher energy content per kilogram than gasoline, so gives more power for the same weight of fuel. Heavy fuels, such as diesel and kerosene, tend to have lower volatility and knock resistance, but higher energy content per litre or gallon. Lighter fuels, such as gasoline, generally have high volatility and knock resistance, but less energy content per litre or gallon. A range of fuel additives are used to change a fuel's performance characteristics. For many years, lead was added to fuel to increase its octane rating, but as the environmental damage caused by lead pollutants was identified, lead was replaced by other less harmful octane-improving additives such as MMT. Gasoline at the pump contains a number of other additives to do such things as improve combustion, reduce internal carbon buildup, and improve starting in cold weather. Alternative fuel sources are used as a way of reducing the operating cost of vehicles, or to reduce pollution from vehicle emissions, or both. Some alternative fuels can be mixed with gasoline as a fuel additive to reduce the total amount of gasoline used. Others are a complete fuel alternative, which may require some modifications to the vehicle. Ethanol is usually derived from an organic process, such as the fermentation of sugarcane, and is therefore referred to as a biofuel. It's normally used in the ratio of 9:1, or 9 parts gasoline to 1 part ethanol, and is primarily used to reduce the negative emission effects of gasoline. Methanol is produced from wood or other organic materials. Its calorific value or burn rate is not as high as that of gasoline fuel, and cannot be used in conventional vehicles without significant modifications. Liquefied petroleum gas, or LPG, is a petroleum-derived colourless gas and has been used for many years to power specially modified gasoline engine vehicles. It is the third most common fuel and emits much fewer harmful emissions than gasoline. It's generally cheaper than gasoline and is non-toxic and non-poisonous with a very small flammability range. It's popular with high mileage applications such as taxicabs, where the cost of vehicle modification can be recouped over time more easily through lower fuel costs. Compressed natural gas, or CNG, is being used as an alternative fuel in vehicles such as light-duty passenger vehicles, delivery trucks and buses. CNG-powered vehicles use natural gas stored in cylinders at pressures of 2,000 to 3,500 pounds per square inch, or 140 to 240 bar. Liquefied natural gas, or LNG, is being used in heavy-duty diesel-powered vehicles such as long-haul trucks, delivery trucks and buses. LNG is almost pure methane and has an energy storage density much closer to gasoline than CNG, but for the gas to become a more compact and easily stored liquid, it has to be cooled to an extremely low temperature, minus 263.2 degrees Fahrenheit or minus 164 degrees Celsius. The need to keep the liquid very cold at all times limits the more widespread use of LNG. Natural gas, whether liquefied or compressed, is less expensive than diesel, and natural gas vehicles are substantially cleaner than comparable diesel vehicles.